Okay, so the last section from this unit is kind of a simple application. Now remember, simple doesn't mean easy. That's not me talking down to you. Simple just means that there are more complex ways that we could apply in a real world situation this idea of sets. But this is just to give you a taste of if you went into certain areas, how you might take this concept of sets and apply it in a real way. And so one of the ways, or the way that we are going to look at, is with what's called a survey problem. And it's to figure out the breakdown of a population or of a sample of those surveyed and see how they fit some constraints. So I've got two examples I'm going to do. You've got, I think, three examples that you're going to do, and you're going to ask whatever questions that you have of me as we go through. So here's my first example at the top of page 1. So here's the situation. We're at this community college, and we took a survey to determine where students studied on campus. Okay, we know we asked 250 students this, and it was determined that 167 people studied in the library, 138 studied in the cafeteria, 75 studied in both. Okay, so real simple problem, not a whole lot of options just because we are just learning how to do this. But if you remember from our last time what the different regions of our Venn diagram mean, then you shouldn't really have any sort of big issue with this. So what we're going to do is we're going to draw a Venn diagram with that information we are given, and then we'll answer the questions. The questions will come about naturally from looking at our Venn diagram. Okay, so here's my Venn diagram. Now, as I'm drawing this, help me out here. How many sets, how many circles do you think I need on my Venn diagram to divide up these students? Why do you say 3? Okay, so I just want to help think this through because I don't see 3 things, I see 2 things. So I see that we need a library circle, and then we need a cafeteria circle, because those are the two options that the students are picking from. So like if you're seeing a third, maybe you're meaning the universe would be kind of the third area. But like what we'll see in my second example when we circle back around is we will also do a problem that has 3 categories that will have 3 circles. So thank you for participating, though. I love that you're bold and helping me out here. So what I'm gonna do is I'm gonna draw a Venn diagram, and I'm gonna have 2 circles because there's 2 options that these students had to give. Again, we're keeping this nice and simple. I'm going to label the circle on the left. It doesn't really matter. I'm going to label it the library. And on the right, I'm going to label that the cafeteria. I'm just abbreviating. Hey, Perkster, if I labeled the one on the left cafeteria and the one on the right library, am I going to get the problems wrong? Not at all. Okay, that is immaterial. That is not going to affect your rightness or wrongness as you do this problem. So now what we're going to do is we're going to put numbers of students in each of the appropriate places. As we saw last time, there are 4 different areas on this Venn diagram. Help me out in what they mean before we put numbers in this. So this part of the library circle that looks like a cookie that somebody's taken a bite out of it. What does this part of the library circle that I'm tracing represent? Okay, let's be a little more specific because perfect. Yes, thank you. Okay, so this is how many students studied in the library, but not the cafeteria. Or another way you might see this as you're working your homework or going through these examples is how many studied in the library only. Okay, not in any other option. Does that make sense? Okay, so take another swing at this. How about this part of the cafeteria circle that looks like a cookie with a bite taken out of it? How would you describe this in words? Only in the cafeteria, or cafeteria, but not the library. This middle part, how would you describe that? That's the intersection. That's both. And then we've got our universe, which is students who studied somewhere else. Okay, so we're going to now put the appropriate number in the appropriate place. And my only tip that I have for you in this, it shouldn't be, I think once we've done a couple, this should not be hopefully a super complicated thing. It's just always start with the most specific piece of information, then work your way up. So the most specific piece of information I'm given in this problem is that 75 studied in both. Okay, so this is a very specific detail. So that means, where am I going to put 75 students? In what region of my Venn diagram? In the football, in the intersection. I'm going to put the number 75 right here. 75 students studied in both. Tracking with me so far? We doing okay? Because you're going to do your own on the next page in just a moment. Now I'm going to work my way up the ladder. I started with the most specific piece of information. Now, 138 students studied in the cafeteria. Now here's the most common mistake. And I want you to help me understand why. Don't write this down. That's why I'm going to write this in pencil. The most common mistake is for students to go, oh, okay, I'm going to put 138 right there. Who can tell me why that is not the appropriate thing to do? Yeah, this says, don't read more detail into this than the words are giving you. This says 138 studied in the cafeteria. Does this say they studied in the cafeteria only? Does this say they studied in the cafeteria but not the library? No. All it says is cafeteria. So what that means is not that there's 138 there. What it means is that I have 138 students total in the cafeteria. Now, there are problems. You might encounter one that says 138 studied in the cafeteria only, and then you'd be right to put 138 there. Does that difference make sense? That's the most common mistake students make. If you can overcome that, you're going to have no problem with these problems. Okay, so if 138 students are in this circle, okay, I've already accounted for 75. That means how many are left for this part of the cafeteria circle? How are we going to get that? Yeah, 138 minus 75. It's a little early. I haven't had a whole lot of caffeine today, so I'm going to open up the calculator. Okay, and we're just going to let the calculator do the work here. So that's 138 minus 75, and that is 63. So I'm going to put the number 63. And notice, 75 plus 63 adds up to 138. I've got 138 students in the cafeteria. So do this. I'm going to give you 15 seconds. 167 studied in the library. So what are you going to write in this part of the library circle? Tick, 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 tick. And what did you write in there? Where'd you get the 92 from? That's 100% correct. Bam, yes, taking the 167 and subtracting 75 from that. So now, between 92 and 75, when I add those together, I have 167 students in the library circle. Lastly, I need to figure out my universe. Anybody got a thought, a hypothesis for me on how I can figure out how many students are in the universe? Perfect. In case you did not hear, what she said is I'm going to add all three of these numbers up to see how many students I've accounted for. And then I'm going to subtract that from the 250, which is my total that were surveyed. All right, I see some people working with the calculator. When I add these three numbers up, what do I get? You get 230, and then yes, you were just one step ahead of all of us. We get 20. So 92 plus 75 plus 63 was 230, and I subtract that from the universe of 250, that leaves me 20. Okay, that's the hardest part. Once you've filled in the spaces, all the questions are now is asking you to write down the appropriate number. So let's answer these questions. How many students did not study in either the library or the cafeteria? How many is that? 20? Yep, those are the students that did not study in either of those places. They studied at their kitchen table or at Panera or something like that. Okay, how many studied in the library but not the cafeteria? 92, great answer. How many studied in the cafeteria but not the library? Yep, for sure. And then how many studied in either the library or the cafeteria? So when I ask for or, I want to know How many studied in one or the other or both? So when we added that up, how many was it? 230. Yep, exactly. Great job. All right, now I want you to process this and do one of your own. So what you're going to do is you're going to flip to the second page of our examples here, and you're going to do exercise 1 at the top. It's a super similar problem. Okay, just change the theming of it a little bit. And so I would like you to fill in your Venn diagram and then answer the questions. And if you want yours to look exactly like mine, remember it doesn't have to. I am going to put the pumpkins on the left. So let's see how you did on this first one. So it says during the fall festival at this farmer's market, 200 customers made the following purchases. 109 purchased pumpkins, 98 purchased pies, 61 purchased both of those things. Okay. So help me out. What's the most specific piece of information we are given about this? 61 purchased both. So we're going to put a 61 right there. I would guess that all of you had no problem with that. Now, here's where we want to avoid any issues. 98 purchased pies. So that means, what am I going to put as my value right over here? What was that? 37. Yes. Okay, because again, that does not say, don't read extra detail, does not say they purchased only pies. It just says very general statement, they purchased pies. So that means 61 and 37, that's the 98 people right there that purchased pies. Okay. 109 purchased pumpkins. And so when I take 61 and I subtract it from 109, that gives me, I believe, 48. And last but not least, to get the fourth part, the universe, what do I get when I add these three numbers up? I'm sorry, you said 146? And then I subtract the 146 from the 200, and that leaves me 54 people that just browsed or purchased other things, and we're not concerned about them. 54, okay, so what we did to get the 54 is we took these values right here in my Venn diagram. So I took the, gotta turn it on. I took the 48 and then plus the 61 and then plus the 37, and I got 146. Okay, and then you take that and we were told the universe is 200 people. There should be 200 people in the whole square. And so 200 minus the 148 is the 50. Oh, was it? I think I must have added something wrong. So hang on, that said 148. Or did I just remember wrong? Was it? Short-term memory problems. I'm getting old. That's 146. So now I take the 200 minus 146. That's better when you use the appropriate numbers and you get 54. Okay. All right. Now I'll answer the questions. How many purchased only pumpkins? And that is 48. How many purchased only pies? 37. And then how many did not purchase either of these things? And that's the 54 out there in the rim of my Venn diagram. All these things work the same. Once you get the hang of it, it's not going to change. I'm going to do one more example. As I alluded to previously, this example has 3 circles. And if you got more complicated, you can do this with 4 or 5 or 6, all sorts of different amounts. But again, we're keeping this relatively simple because you're just learning it for the first time. So here we go. Example 2, we work for a travel agency and we surveyed 125 potential customers. And here's the information we got. 68 people wanted to go to Hawaii. 53 wanted to go to Las Vegas. 47 wanted to go to Disney World. 34 wanted to go to Hawaii and Vegas. 26, Vegas and Disney. 23, Hawaii and Disney. 18 wanted to go to all 3 of those things. So again, as we're going through and we're plotting and putting our numbers in the Venn diagram, do not read into this more detail in a statement than is there. This time I need 3 circles in my Venn diagram because we have 3 options on this particular survey. And also remember, it does not matter what order you label the circles in, you will get the same answers as I do. I'm going to just go in the order that they're presented. Hawaii is going to be the first circle for me. Las Vegas is going to be the second one. And then I'll put Disney World down here as the bottom circle. That is an arbitrary choice by me. Okay, so I have no real reason for doing that other than in the order that I read the words. Okay. So now, there's a bunch of statements here. And in my Venn diagram, I got 8 regions I've got to fill in. What's the most specific piece of information I am given on this problem? Yeah, all 3. There's no generalization about that. There's no other way to read it than 18 wanted all 3. So I'm going to put 18 people in there in the middle where all 3 circles overlap. Now I'm going to work my way up the ladder. 23 wanted to go to Hawaii and Disney. So the next statement right above. Now, again, don't read that as Hawaii and Disney, but not Las Vegas. That's not what it says. Okay. It says there's 23 people in the Hawaii and Disney football. So the football here that I'm tracing. Well, how many people are already in that football because of the space we filled in? 18, yes. So how many people see these 18? They want to go to Hawaii and Disney World, right? They also just happen to want to do something else, but that has no bearing on this statement right here. So how many people does that leave for this bit of the football? 5, yes. And that 5 is the 23 people that want to go to Hawaii and Disney minus the 18 people that are already lurking in there. And that leaves me 5. So 5 and 18 is 23. Let me help you with the next one, and then you can do the last of the intersections. 26 want to go to Vegas and Disney. So here's the Vegas and Disney football over on this side of the Venn diagram. And once again, how many people do I already have that want to go to Vegas and Disney World? 18. It just happens that those 18 want to also go to Hawaii, but that has no bearing, again, on this statement. So that leaves me that I have how many that I'm going to put in this part of the football? 8, yes. 8 and 18 is 26. All right, I'm going to give you 15 seconds. The next one, 34 wish to go to Hawaii and Vegas. Fill in the next space on my Venn diagram. And what did you write in this part of the Hawaii and Las Vegas bubble here? Where'd you get the 16 from? You got it. Perfect. There are don't be sorry. There are 34 that wanted to go to Hawaii and Vegas. Here's the Hawaii and Vegas eyeball or football, whatever you want to call it. There are already 18 people in there, so that leaves 16. 16 and 18, that joins up to have 34 people in that overlap between the Hawaii and Las Vegas circle. Next up, 47 people wish to go to Disney World. And again, I know I'm saying this over and over because I want you to avoid any issues. This does not say only Disney World, so do not put 47 down here in the bottom. It says in that Disney World circle, no matter what other things are going on, there should be 47 people. So far, I've got 8 and 18, that's 26, and 5, that's 31 people in the Disney World circle so far. So that means that there are 16 out here. Because all 4 of these numbers, if you add them up to check me, all 4 of these numbers, 16 and 8 and 18 and 5, should add up to this number 47 that we just read right there. So do that for the Las Vegas circle. I am told that 53 people wish to travel to Las Vegas. Okay, so 53 wanted to go to Las Vegas. How many people are presently in the Las Vegas circle before I fill in the last part? Yep, 16 and 18 and 8 makes 42. So I'm going to take those 42 people. They're already accounted for. I'm going to subtract it from the 53, and 53 minus 42 leaves me 11 people. Okay. All 4 of those numbers, 11 and 16 and 18 and 8, should add up to the 53 people I'm told are in the Las Vegas circle. Last but not least, do the Hawaii circle, please. Right, 68 people should be in the Hawaii circle. And so far I've got 16 and 18, that's 34. And then 5, that's 39. And when I subtract 68 and I take away that 39, that leaves me 29 people. So all 4 of those numbers should add up to 68. Last but not least, I'm told that I talked to 125 people total. So this gives me the clue that I need to figure out the last space, the universe, the outside rim of this. And so what I'm going to do is I'm going to add up all of those values that we have so far. So that is 29 plus 16 plus 11 plus 5 plus 18 plus 8 plus 16, and that gives me a grand total of 103. So we have accounted for 103 people that we talked to, but the survey problem says we talked to a total of 125, so that means there are 22 more. So that is 125 minus the 103 leaves me 22 for the outside of my Venn diagram. Now, I know there's a bunch of details there. Are we doing okay? Are we following along okay? You're going to go through and do this twice on your own just to make sure everything gets locked into your memory so that when you go home and you do your homework, it's there and you can look at your notes to jog your memory. Okay, the rest of this then, once you've done the hard part to this problem is filling in the Venn diagram. Now I'm just going to ask you, how many people did not wish to travel to any of these places? And that is the 22 that we just saw in the outside there. How many wish to travel only to Hawaii? What number represents the only Hawaii people? The 29. Now let's read carefully. I've underlined to help us on this problem. How many wish to travel to Disney World and Las Vegas? And means what? They want to do what? Both of those things. Okay, so how many want to go to Disney World and Las Vegas, but not Hawaii? Which number represents Disney and Las Vegas, but not Hawaii? 8, this 8 right here. Yep, for sure. How many wish to travel to Disney World or Las Vegas? Now, or means one or the other, but in survey problems, in sets, it also means both. Okay, one or the other or both. When you go to McDonald's and you order a cheeseburger or chicken nuggets, you're not getting both. Okay, that's called the exclusive or. That's how we mean it in kind of like plain language. But mathematically, most of the time, or means inclusive. It means one or the other or both. Okay, so how many want to go to Disney World or Las Vegas, but not Hawaii? Which numbers am I going to add up for Disney World or Las Vegas, but not Hawaii? Yeah, let me underline those for you so that you remember where they are. Disney World or Las Vegas, but not Hawaii. So we're staying outside the Hawaii circle. It's that 11, it's this 8, and that 16 right there. Those are people that are in the Disney World and or the Las Vegas circle, but they're outside of the Hawaii circle. And how many people is that? 35 when I add those up. Great. The last problem says, how many want to go to exactly one of these places? Okay, so this is a little bit of a different question. Three circles allows us to ask a couple more interesting questions. Which numbers represent the exactly one people? Yeah, I'm going to draw a circle around these ones. So it's the 11, I was told, the 16, and the 29. Those are the people that only wanted to go to one place. Okay, they knew exactly what they want to do with their vacation. So 29 and 11, that's 40, and 16, that is 56. All right, we're going to turn the page. You're going to do the next one, okay, on this exercise 2. It also involves 3 Venn diagrams. I'm going to give you 3 or 4 minutes to fill in the Venn diagram and do as much as you can. Okay, if you need anything, raise your hand. I will come to you. All right, let's take a stab at this. I'm going to go through this problem. If you get a different number than I do and it's not clear to you why, then by all means, let me know. I'll explain it a different way and see if I can help you gain some clarity. So on this particular problem, we got 85 customers at the Barnes and Noble, and we want to know what kind of books they like. And so we found out this bit of information right here. So the same thing is true as before. I'm going to start with the most specific piece of information, and that's at the bottom. Two people, they purchased all three of these different types of books. I've got mysteries, I've got science fiction, I've got romance novels. So I'm going to put two people right in there in the middle that bought all three of those. 11 purchased mysteries and romance novels. So here's the mysteries and romance novels football. And I've already got two people in there, so I need 9 more to make 11. 5 purchased science fiction and romance novels. So here's the science fiction and romance overlap. I've already got 2 people in there, so I need 3 more to make a total of 5. 13 people purchased mysteries and science fiction. So here's the overlap of those two things, mysteries and science fiction. I've already got 2 people in there, so I need 11 more to make 13. 29 purchased romance novels. So I need 29 people total in this one. So I've got 9 and 2 is 11. Plus 3, that is 14. And so I need 15 more to make 29. We doing okay? 33 purchased science fiction. So here's the science fiction circle. I've already got 11 and 2, that's 13, and 3, that's 16. So 33 minus 16, is that 17? All right, thank you for your subtraction help. And then finally, 44 purchased mysteries. Here's the mystery circle. I've got 11 and 2, 13 again, and 9, that is 22. So that is 22 more. And last but not least, I need 85 people total in this box. And so when I add up 22 and 11 and 17 in all of these, so 22 plus 11 plus 17 plus 9 plus 2 plus 3 plus 15, that gives me a grand total of 79. And so that means I need 6 more out here to make 85. And there's all my numbers. Again, once you got that, that's the hard parts of the problem. The rest of this should be gravy. Okay, questions, anything? Okay, so how many people purchased only mysteries? That is the 22 that are in the outside there. How many purchased mysteries and, so there's the word and science fiction. So how many purchased both of those things, but not romance? So mysteries and science fiction, but not romance is these 11 people right here. How many purchased mysteries or science fiction? Now notice there is no but not, there's no only. So I want everybody in the mysteries and everybody in the science fiction circle. So mysteries and science fiction, that is 22 and 11, that's 33. And then plus 17, that's 50. Plus 9, that's 59. Plus 2 is 61. Plus 3, that's 64. Okay. Notice that problem did not say mysteries or science fiction, but not romance novels. That's the next one, actually. So fun. We get to do that too. Mysteries or science fiction, or means one or the other, or both, but not romance. So that is 22 and 11, 33, and 17. That is 50. And then last but not least, what numbers there represent the answer to the question exactly 2 types of books? The 11, the 9, I'm circling them in 3. Those are the places that are exactly 2. And so 9 and 11 is 20 plus 3, that is 23 people. All right, just one more fun, just because we have the time. So exercise 3, our last exercise for this unit. It's the same thing that we just did, just different numbers, different situation. I'm going to give you again 3 or 4 minutes. Grab your calculator. You can use your phone for your calculator and work on this, and then we will run through it together in just a minute. All right, so I'm going to get started on this. Once again, the invitation for you is if you get a different number and don't understand why, let's talk about it. You notice on this one, you're given two pieces of detailed information. You're not told at the beginning how many people total were surveyed, but you'll be able to figure that out. So just a little bit slightly different, but not too bad. So we surveyed college students and we came up with the following results about how many owned iPads versus laptops versus gaming systems. So I'm going to start right down at the bottom. 26 owned none of these devices. And so that means hopefully we put the number 26 out here in the universe somewhere. 68 owned all three. So again, that's specific information. There's no other way to interpret that than that 68 goes here in the middle. I got my calculator at the ready for some of these numbers. So 139 owned a laptop and a game. So here is the laptop and game overlap. I need 139 in there. So 139 minus the 68 that are already in there leaves me 71. 200 owned an iPad in a game. So here's where the iPad and games overlap. I've already got 68 students in there. So 200 minus 68 is 132 students in that part of the overlap. Those two things add up to 200 now. 193 owned an iPad and a laptop. So here's where those two circles overlap. I need 193 in there. So I'm going to take the 193 minus the 68 that are already in. So 193 minus the 68 that are already in. That's 125. And the last three numbers just refer to the big circles. And so 285 owned a game. So I'm going to add up those three numbers of the students that we already know own a game, and then I'm going to take that from 285. So that's 132 plus 68 plus 71. That turns out to be 271 that are already in there. So 285 minus the 271 is going to be 14 students left over that only have a game and nothing else. 293 on a laptop. So here's my laptop circle. I know three of the regions in there. So I'm going to take the 125 and then plus the 68, then plus the 71. And that means so far I have 264 people in that circle, and I need 293 total. And so when I subtract those two things, it looks like I'm going to get 29 as the result. And we've got one more region, and then we will be at long last done. 356 owned an iPad. So I need to figure out how many are in this last region. So I'm going to add up what I know, 132 people plus 68 plus 125. That gives me 325. I'll write that down here. And there are 356 total. When I subtract that, that is 31 left over. And now we can answer the questions. Well, the first one, how many were surveyed? How am I going to figure out how many students we surveyed for this? What do I do? Add up all those numbers. Yes. And when you added up all those numbers, what did you get? Yep, that is correct, 496. And we got that by adding up all 8 regions. That is everybody. How many owned an iPad and a game, but not a laptop? So iPad and a game, but not a laptop. So here's the iPad and a game, not a laptop. That's 132. How many owned a laptop, but nothing else? And so laptops, but nothing else, that is how many people? 29. That's just another way to say how many owned only a laptop. How many owned exactly 2 devices? What numbers, and I'm going to circle them, what numbers do we add up to get only exactly 2 devices? Yep, those are the people that own 2 only of those devices. And when we add those numbers up, we get 328. 100%. And then how many owned at least two? What do the words at least mean? Both, and then at least means both or more. Okay, at least two means two or more of these things. So I have to add one more number into this. What's the one more number I have to add into what we already have? Yeah, that's 60. I'm just going to put a box around that. That is the two or more, at least two. And so when I add 68 to 328, I get 396. And there we go. There's your survey problems. It's all just an exercise in knowing what the different regions are telling you.